Hi everyone, welcome to day 2, your coterminal and related angles. You got introduced to that definition yesterday. Today we're going to get more into it and how it applies. Okay, there is a lesson down here. I'm actually going to do the examples first and then come back because it will make a whole lot more sense after we look at some examples. Okay, all right, so I want you to imagine again that we have a circle. It's not our unit circle, but it is a circle. And on this circle, we have the point 3, 4. So if we look at it, our y value is 4, our x value is 3. We can use Pythagorean's theorem to figure out the hypotenuse. So this, so this angle here is, this length here is 5, okay? So we have a 3, 4, 5 triangle. So what they would like us to do is determine our, we'll say, exact trig ratios. So sine of theta is opposite over hypotenuse. This is simply 4 over 5, okay? This should say cos. There we go, cos. Cos of theta is adjacent over hypotenuse. It is 3 over 5. And tan is opposite over adjacent. It is 4 over 3. So if we're trying to figure out our trig ratios, honestly, that's all we're looking at. Okay, so what I want you to notice right now is that this one is positive, this one's positive, this one's positive. So in our first quadrant, they are all positive, okay? All right, let's go down to a second example. We have another point on our circle. This particular point is -7, -2. So this, our x coordinate is -7. Our y coordinate is -2. We have a right angle triangle and we're looking at this angle right here. So remember, even though this whole thing is the angle, we're only looking at the triangle down at the bottom. Okay, we're just looking at this little related angle instead of the whole principal angle. So sine of this little angle, oh, sorry, before we can figure out sine, I would need my hypotenuse. The reason we call it r instead of h is for the radius of the circle, but it's the hypotenuse of the triangle that you create. So use Pythagorean theorem to get, you should get the square root of 53. I'm going to keep it as root 53. Okay, I can't simplify that and I do not want decimals, so I'm going to leave it there. So sine is opposite over hypotenuse, so sine is going to be -2 over root 53. Okay, cos, again, this should be cos. Cos is going to be adjacent. Sorry, adjacent over hypotenuse. So this is going to be -7 over root 53. And tan is going to be opposite over adjacent. So -2 over -7. But when you reduce the two negative values, you should get +2 over +7. So in this quadrant, tan is the positive one. Okay, so up here they were all positive, and down here tan is positive. Okay, let's look at those again. Okay, here is a third point. Again, use Pythagorean's theorem. So the x is -6, the y value is 3, the hypotenuse, use Pythagorean's theorem. I did it earlier, you get 3 root 5. And we're using this triangle right here. Sine is opposite over hypotenuse. So this is 3 over 3 root 5. If you simplify this, you should get 1 over root 5. Now, your book that I've given you may leave it here. Other books or sources might do something called rationalizing the denominator. I'm going to post a separate video. Essentially, what happens when you rationalize the denominator is when you're left with a radical on the denominator, you multiply both the top and the bottom by that radical. So it would be multiplied by root 5 over root 5. Okay. And the reason that we do that is to eliminate the radical portion on the denominator. So root 5 times root 5 is +5, and you end up with root 5 over 5. Okay. Again, I'll post a video at another point about rationalizing, or just look it up about how to rationalize. So this is our answer right here, but if you rationalize the denominator, it would just look like that. So it's two different ways to make it look. Okay, cos of our angle, is adjacent over our hypotenuse. So this is -6 over 3 root 5, which would give us -2 over root 5. And if you decide to rationalize the denominator, you would have ended up with -2 root 5 over 5. Okay, so you could have written it this way or the second way. Again, though, notice please that our sine is positive, our cos is negative, and now we're going to look at our tangent. Tangent is opposite over adjacent, 3 over -6, which is just -1 over 2. Okay, so again, we found 3 ratios, and out of all of them, sine is the positive one up here. So right now, all of them are positive. Sine is positive, tan is positive. Last example. Oops. Consider another point. We want to draw our triangle. We are always drawing our triangle with the x-axis. Okay, so the y value would be -5, our x would be 2, our hypotenuse. Use Pythagorean's theorem to get the hypotenuse. I already did it, it's root 29. Sine of theta would be opposite over hypotenuse, so -5 over root 29. Again, rationalize your denominator. You should get -5 root 29 over 29. Cos of theta is adjacent over hypotenuse, which is 2 over root 29. You can rationalize the denominator. That would be your answer, but rationalize it, please. You should get 2 root 29 over 29. And tan of theta is opposite over adjacent, so -5 over 2. You'll notice that in this quadrant, tan is negative, sine is negative, and cos is positive. So here, cos is positive. In the first quadrant, they're all positive. In the second quadrant, sine is positive, and in the third quadrant, tan is positive. So we can write CAST, and this is going to be known as your cast rule. So let's go back to our very first slide. Okay. Basically, what you need to get out of this section is that sine is equal to the y value over the radius, cos is the x value over the radius, and tan is y over x. You can find the radius using Pythagorean's theorem. That's all that is. Okay, it's Pythagorean's theorem. And when you do it, all of your values are positive in the first quadrant. Only sine is positive in your second. Only tan is positive in the third, and only cos is positive in the fourth quadrant. That's what this is saying. Okay. Pairs of related angles are found using the coordinates and their endpoints. You use the reference angle in the first quadrant. So basically, you're making your triangle with your x-axis, is what it was trying to tell you. And coterminal angles are angles with the same terminal arm. So if I had an angle down here, right, this was the related angle to something that would be over here, right? You just continue to reflect it to work with the easiest triangle. But if you look at the examples that I did on down below, oops, if you look at these examples, it's really saying what I've shown you earlier, okay? It's just a summary. All right, so now let's use all of that to get our actual answer, or an actual question. So it says, solve this for angles between 0 and 360 degrees. Okay, cool. So 360 degrees is a full circle. So we're just looking at one rotation. So we need to find this. So we've got to consider a triangle. Now remember, sine is y over r. Okay, so our y value is 15 and our hypotenuse would be 17. Now the hypotenuse can never be negative because you can't ever have a negative under a root sign. So our hypotenuse will always be a positive value. That means that the negative goes on to the 15 here. Okay, they talk about your cast rule. I like drawing diagrams to make things easier. Okay. So if sine is negative, remember C-A-S-T, that means that we are looking at either this quadrant or this quadrant because sine is positive here, right? Sine is positive and all of them are positive here. So if sine is negative, it's got to be one of the bottom two guys. Now, my R has to be a positive value because our radius is always positive, which means the y is 15 negative, which is down. So we're either looking at this triangle or this triangle, okay? So this would be negative 15, negative 15. Our hypotenuse is 17, hypotenuse is 17, and our job is to figure out what the angle is. So we can use our basic sine ratio, right? So sine of theta equals negative 15 over 17. Our calculators struggle with the negatives, so what I want you to do is ignore the negative, okay? Pretend, because the smallest angle that we'll deal with is the one in our first quadrant, and then we just reflect it where we need, okay? So sine of theta equals 15 over 17, just ignore the negative. Use the inverse sine to find theta, right? Just plug it into your calculator. You should get 62 degrees. Okay, so if 62 degrees is up here, that means if you reflect it, this is 62, and this is 62. But we have to get those angles from our initial arm that has been rotated all the way around. So I'm going to travel up 90, 180, so this is 180 plus 62. Oh, they did it for us. There's the 180 plus 62. So if we're in this quadrant, our angle is 242 degrees. And if we're in this quadrant, I'm going to have to go, actually, you can do it a couple ways. I can either go 60, I can either go 0, 90, 180, 270, and then whatever is remaining between 62 kind of and 90. So this is 28 degrees. So I can go 270 plus 28, or you can take 360, because a full circle is 360 degrees, minus 62. I don't particularly care which way you do it. Okay, so we're looking at an angle of 242 degrees or 298 degrees. So it is possible to have two separate answers. Okay, so you've got to look at all the possibilities using your cast rule and using your basic primary trig ratios. Okay, that's it. Good luck. And again, if you want to see other examples, use your textbook. I've referenced each section. So if you look at 5.3 and 5.4, this one's specifically 5.4, you can find lots of other examples there. Okay, guys, have a great day. We'll see you for the next section.